or is it done?
As soon as you're done, it's like college. As soon as you're done, you peace out, Girl Scout. You get a little pass, you go back to class. That's the awesome part about college. When you finish the test early, if the professor doesn't make you stay, you literally can just walk out of class. Just, here's my test, bye. See you later. Okay, I am gonna record this because this is kind of difficult, so that way you guys can go back and look at it. Today is the, 31st? Essential question, how do I determine the amplitude and period of this word is called sinusoidal function. So what do you guys think we're going to be talking about with that? Sine. Well, that's crazy. But this really means, make a note to yourself, a sinusoidal function really means sine or cosine. Okay? Because you guys are going to see in these notes that the graphs are kind of similar, but they differ in a couple important ways. So what are you guys going to learn this week? How to graph. It's crazy. You guys will learn how to graph sine and cosine. Use what's called amplitude and period. We've already kind of talked about period, right, last week? To sketch sine and cosine functions. And then we're going to sketch transformations of sine and cosine functions. All right. These have a lot of steps, okay? I promise you guys these are not that hard. If you guys pay attention, if you guys ask questions, if you guys just kind of shut down on me and be like, oh, this is hard, whatever, you're not going to get a lot of points when you guys graph these on your tests because your next test is going to have these on it, okay? And these questions you can't use a calculator for. So you can't just ask your calculator, graph this for me, and then copy it on your test and then be like, that's done. You won't be able to use your calculator on this question on your test. All right, so let's talk about the sine graph first. So don't put any boxes in yet. We're just going to talk about this first. So if you guys are looking at your unit circle, this is basically where this idea is going to come from. We can graph one, bless you, period, or one cycle of y is equal to the sine of x by using some key points. Okay, so just to keep things simple, in case you guys are wondering why, we're going to start at 0, just to make things easy. So what I want you guys to look at is on your unit circle, remember, is sine x or y? It's y. So if you look at your unit circle at 0 degrees or at 0 radians, what is the sine of 0? 0. Okay? Now here comes the cool part. For graphs, you can choose whatever numbers you guys want. So if you guys look at your unit circle, I'm going to kind of draw my janky unit circle right here, but you guys have it in front of you, so you don't have to draw this part. So right here is 1, 0, right? If I want to pick numbers in my table, what is the sign right here? 1/2. What type of number is that? 0.5. So it's a decimal, right? If we have a choice, though, I don't want to graph decimals or fractions. Okay, so that's the kind of the mindset I want you guys to think about. So this at 30 degrees or pi over 3 or pi over 6, it's 1/2. What about right here? Square root 2 over 2. Again, is that going to be a pretty number? So let's keep going. And we get square root 3 over 2. Again, is that a pretty number? No. What about right here? That's 1. Would you guys be comfortable graphing that? Yeah. So what's the angle at the top? The angle, pi over 2. Bless you. All right, so if I keep going around the unit circle, do you guys agree that this number is going to be the same thing as this number, but just negative? Mm-hmm. So ugly, ugly, ugly. What's the sign right there? 0. So what's the angle right there? Pi. So at pi, we have 0. And if I'm following this pattern, ugly, 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 3 pi over 2, which is negative 1. And then if I keep going, if I wrap all the way around, what would that be? 2 pi. And what's the sign there? 0. Okay. This is really why we're picking those numbers. Make your life easier, not harder. Do you guys want to graph decimals and fractions if you guys don't want to? Already, you guys see how we already have some fractions over here. And that's only because those are our angles. Okay, so do you guys remember last week me telling you guys that the period of sine is 2 pi? That's because after 2 pi, everything's going to start to repeat again. Okay? So the period, one period of sine of x is 2 pi. And hopefully that makes sense. If I travel from 0 all the way to 2 pi, do you guys agree that distance is 2 pi? Right? Because 2 pi minus 0 is 2 pi. Okay, so let's sketch what this looks like. Now, I kind of spoil you guys because I normally give you guys graph paper. For these, we're actually going to just graph by hand. So we're going to draw our axes by hand, and we're going to label everything by hand. So if you guys want to use a ruler, you can, but you don't have to. So do you guys agree this is 0? And then what I want you guys to notice is how far apart are these angles? Half a pi, right? Pi over 2. How far apart are these angles? Pi over 2. Pi over 2. Pi over 2. That's important. This is our scale. Each distance between our little tick marks on our x-axis. So should I draw them like this? No, they should be equally spaced apart. So I'm going to draw pi over 2 like right here. And this distance, I'm going to try to like copy paste. So I'm going to try to use the same width. So this would be pi. And this would be 3 pi over 2. And then this would be 2 pi. So that way we get a nice wave. You guys will see what I mean right now. This is going to be 1. I'm going to make this negative 1. So let's go ahead and plot our points. So 0 gives me 0. At pi over 2, we know it's 1. At pi, it's at 0 again. At 3 pi over 2, we have negative 1. And at 2 pi, we have 0 again. So for trig functions, they're gonna look like a wave. So don't do that. It needs to look like this. Like a rounded little hills. Okay. Is everybody cool so far? Now here comes the cool part. How many cycles was this? Just one cycle. So this gives us one glimpse at what the sine wave looks like. Okay? But it doesn't just stop here. What would happen is, do you guys see how at the beginning of this, it goes up, comes down, and then goes back up? Basically what's gonna happen is at 2 pi, a new cycle will begin. So at 2 pi, it's gonna do the same thing. It's gonna go up and down and keep going. Like copy, paste, copy, paste, copy, paste forever. Okay? And then same thing going this way. It's gonna wave, 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 going that way. Okay? You guys will be happy to know that when you guys graph these, almost always, I'm just gonna tell you guys to graph one cycle, just so you guys know what it looks like. Okay? But in general, does that mean that I can do something like this? Like it just keeps going. Okay? And then it keeps going like that. Okay? So in yellow, this represents one period of the sine function. Bless you. So make a note to yourself, because the period of sine of x is 2 pi, we only have to graph from 0 to 2 pi because the rest of the graph will repeat itself. All right. Does anybody have any questions so far? No? No? Are these weird? These are kind of weird. Wait till we get to tangent and the other ones next week. Those ones are really weird. Okay? So, let's talk about some properties. Yeah. All right, so like I was telling you guys, does the graph stop at 0 and at 2 pi? No, it keeps going, right? So if it keeps going forever this way and forever this way, what's the domain? All real numbers, so we're going to say negative infinity. Oops. Negative infinity to infinity. Now the range. Range is the y's, right? What's the highest y value that the graph touches? 1. And what's the lowest y value? -1. Does it touch it, or is there a hole there? It touches it. So do I use brackets or parentheses? Brackets, good. So the range is -1 to 1. All right. We talked about this last week. You don't really need to know this to graph, but just for fun, why not? What's the only trig function that's even? Cosine. Cosine's even, which means what else is even then? Secant. Everything else is odd. So the tangent function is odd. Do you guys have a question? In the corner, do you guys have questions? Do you have a question? I can't hear you guys. The AC is super loud. What's up?
Positive, right?
Say it again?
Are you saying cosine is positive?
No, even or odd.
Oh, but it's saying, oh, wait.
Okay, what's the period of this guy? 2 pi. Now the x-intercepts, what I want you guys to notice is x-intercepts are where it crosses the x-axis, right? So negative pi, 0, pi, 2 pi. So if this pattern continues, where would the next one be? 3 pi, and then 4 pi, and then 5 pi. So what are you guys noticing? It crosses at every what? Pi. So every integer multiple of pi. What type of numbers are integers? Can they be fractions? Can they be negative? Yes. So what type of numbers are integers? Whole numbers that are positive or negative. So if I take any whole number, like 7, and multiply by pi, that'll be an x-intercept of this graph. Okay? The y-intercept, please highlight this because this is how you're going to start these graphs always. Where does this cross the y-axis? At 0. So the y-intercept of sine is 0, 0. So this is where the sine graph begins. I put begins in quotes because does it really begin there? Because isn't there stuff on this side? But when we graph one cycle, we'll typically start at 0. Do you have a question? Not yet? You're just soaking it all in? Okay. All right. That was fun. Now let's do a problem. All right. So have you guys ever graphed trig functions before? No, right? But remember, this is going to be like our rules that we've learned in the past. So what does it mean when there's a number in the very front? What's that going to do? What type of transformation? It's a stretch. Horizontal or vertical? Vertical. So this means that our graph is going to be a vertical stretch by a factor of 2. Does that make sense, guys? Does that make sense, guys? All right, cool. All right. So we're going to graph all of these pretty much the same way. The first thing that you have to do in order to graph these guys is you have to know what the sine graph looks like. So between now and when you guys take your tests, I need you guys to memorize what the sine graph looks like. So if you guys look in your notes, you guys already have the table for this, right? We're going to use the same table here to help us graph this. So if we just copy and paste our table, guys, which x value did we pick first? 0. After 0 came what? Pi over 2. And then pi. And then 2 pi. Cool. What were the y values? 0, 1, 0, -1, and 0. And what will help you understand the y's is just know that the sine graph looks like this. 0, 1, 0, -1, 0. Okay, now we're gonna vertically stretch this by a factor of 2. So everybody turn and look at me. Do you guys agree that means it's gonna look like this, right? Which axis is that gonna affect, the x or the y? The y. So if I stretch everything by a factor of 2, in other words, does not mean I'm just timesing everything by 2. Okay, so all this means is that all the y's are gonna get multiplied by 2. So take that table, multiply all the y's by 2. So the x's aren't going to change, just the y's. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So take all your answers here and times them by 2. So 0, 2, 0, -2, 0. Huh. Questions? Does that make sense? Yeah? All right. Now, I'm only giving you guys this as kind of like a way to kind of think about how it's going to keep going. I'm not going to give you guys a test question like this. It's just to kind of get you guys thinking what this would look like. Where does this graph normally begin? 0, and where does it end? 2 pi. So I'm going to keep going after I finish at 2 pi. That's what that means. And then instead of starting at 0, I'm really going to start at -pi. So I want a little bit before, and I want a little bit after. Okay, so what we're going to do is we're going to graph from 0 to 2 pi first, and then think about what would happen if I kept going. So I want you guys to draw something that looks like that. And so I don't have to keep scrolling up and down. I'm going to copy and paste my table. So here's 0. I have pi over 2, pi, 3 pi over 2, 2 pi, now question for you guys. What am I adding every time? Pi over 2? Okay, so if I add another pi over 2 to 2 pi, what would that be? 5 pi over 2, good. So this would be 5 pi over 2. And then if I added another pi over 2, what would that be? 3 pi? Which means I didn't make enough space for myself. That's awkward. So I'm going to keep going. Slide this over here. If I added another pi over 2, what would that be? 7 pi over 2. And then 4 pi. So if I go backwards, do you guys agree that going backwards, this would be negative pi over 2? Does that make sense? And then over here, this would be negative pi. So what should you be pretty good at to do this? Unit circle, yeah, but what were we doing right now? What are these? Fractions. You gotta be okay with fractions to do this. All right, so let's go ahead and sketch this. This is 1, so I'm gonna call this right here 2. So if I use my table, at 0, 0, pi over 2 comma 2, pi gives me 0. Is everybody cool with that? All right, so let's use our heads. What's gonna happen after 2 pi? It's gonna repeat, right? So after 2 pi, do you guys see how this is the beginning of a new cycle now? Where does it begin? Am I going up or down from here? Up. So that means at this point, it's gonna be where? At 2. So it's going to be here, and then where? 0, and then where? Negative 2, and then 0 again. Does that make sense? Okay, going backwards. So if this is the beginning of a new cycle, where should this be? Up or down? Down. Good. So this is going to be right here, and then where is this going to be? At 0? Okay. So do the best you can. Remember, don't make it pointy. It should be like a wave. So it should look something like that. Now here, because of the directions, they want us to only graph between those two numbers, right? So I'm not going to put like little dotted little arrows because I'm starting here and I'm ending there only in this case. So that being said, that's going to affect our domain. You guys good? Okay. These are so much fun. Where does this graph begin? At negative pi. So the domain in this case would be negative pi to 4 pi. Now I want to make sure that you guys understand this. This is only the domain because of the directions. If it doesn't say anything like that, it's going to be all real numbers. Okay? What's the range? Negative 2 to 2. Okay. Do you guys have any questions? You stretching? You have a question? Yes, sir.
You were saying that we were allowed to make straight lines and we're still making a curve. This would be something about like linear equations or linear functions when that comes to this.
Linear is only linear when it's linear. Trig functions, every trig function is different. You're gonna learn all 6 in the next like 2 weeks. So sine and cosine are wavy like that.
I was making sure like critical concept linear functions be like that.
Linear is the only function that are like straight lines like that. Okay. Make a note right here. We call this a vertical stretch at the beginning, right? We don't use that language for trig graphs. So, for sine and cosine graphs, to describe a vertical stretch or shrink, we use the word amplitude. So what would be the amplitude in this problem? 2. The amplitude would be 2, so you just write A is equal to 2. You can try. I mean, you could try. Huh? Okay. All right, just real quick, guys. You guys taped in the sine box, right? Last time? Okay. I have extra. Please, if you need extra. Okay. All right, so let's talk about this. So for the rest of this section and the next section, we will use equations of the form y equals a sine of bx plus c plus d, and y equals a cosine of bx plus c plus d to graph transformations of sine and cosine. You guys don't have that in your notes, right? Okay. For functions of the form y equals a sine of bx plus c plus d, or y equals a cosine of bx plus c plus d, the amplitude represents half of the distance between the maximum and minimum value of the function. Okay. What is the period normally for sine and cosine? 2 pi. Whenever there's a b value, so if there's a number in front of the x, then the period's going to change. So the period of sine and cosine can be found by using this formula. Capital T. Don't ask me why we use T, we just do. Okay? T means period. I don't know why. Just go with it. Capital T is equal to, the period normally is 2 pi, right? So 2 pi divided by whatever b is. And then just so you guys have in your notes to look back at later after this class, the period represents the length of the interval for the graph to complete one full cycle of itself before it starts to repeat again. We haven't talked about this yet, but we will. In order to find, if I ask you guys what's the midline, the equation of the midline is y is equal to d. Like before, C represents a horizontal shift and D represents a vertical shift.